Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to do social network analysis with Python, and specifically we're trying to see how to read datasets from a CSV file and do our analysis on it, right? So we'll be using some datasets. We have the Grey's Anatomy, which is a very common dataset. We also have a new dataset we're working with, which is the US President dataset. Then also, in case you want to have several datasets to work with, you can just go to this available website to have datasets to work with, right? So let's see how to work with a CSV file, how to load datasets from a CSV file, and then how to do your social network analysis on that. So social network analysis, as we already know, is just trying to derive information or insight from a social structure. Something like this. That's a basic idea about social network analysis. So trying to derive information from these things. Which of them is a node? Which of them is the edges? So this is a node. This is a node. The individual people inside the structure is an object or an entity or is a node, right? And then the connections between them is the edges. So that's the basic idea about it. So now let's see how to start with it. So we're going to load our packages. So import pandas as PD, then import NetworkX as NS. Then go to load our dataset inside. So df is going to be pd.read underscore csv. Then this is going to be our dataset. It's going to be our US. Right, so that's the dataset that we read. So if I check this particular stuff, df.head, so that is giving us from to, right? So from is the source, then to is the target. So these are all the precedents and then their relationship with one another. Very interesting, very simple dataset. So it's supposed to be able to read it as a list. So that's why we're using the edge list, right? From the network S. Now let's see how to read our dataset into our dataset from pandas into our network S. So it's going to be quite simple. So I'm just going to call it as graph. Right, US graph, very simple to make it quite interesting. Then I'm going to load this to ns.from pandas, right? So we have from this to date, from this to list. There are several formats of reading, right? So we can read your data from different formats, but we're using the pandas option, pandas edge list. Then go to supply our data frame that we have on the top. Then going to give it our source. It's going to be from, that is the name of this column here, from. And then the next one is going to be our target. This is going to be the name of the target, which is 2. Perfect. So let's run it again. Because now, in case I check this particular stuff I have, I check for the type of this, it's going to tell us that it is a network, right? It's a network graph. So it's network S class of graph. Very interesting, very, very interesting. In case I want to get information about this particular stuff, I can just go, let's say, to get info. It's going to be quite simple. ns.info, then I'm going to pass in our US graph that we have. Perfect. So we have these numbers of nodes, that is 19 people in this particular graph, and then the edges are 21 different edges. Very interesting. So now let's see how to check for all the nodes or objects of people. So a node or an object, as we already learned, is just these individual ones. So these are the individual nodes. The edge is the connection between them. So let's check for the individual nodes. So check for the individual nodes. It's going to be very simple. It's going to be our US, right? We have our US graph as our graph itself. Dot nodes. I'll go with dot nodes. It's going to list all the nodes in this particular object. So we have all these different nodes, which is very interesting. So in case I want to get the length of this node, I can just do the normal stuff of length. Paste in this, then I'm going to get the length, which is 90, just as it showed here as 90. Perfect. Now in case I want to check for all the edges, the different connections between them, just go with US underscore graph dot edges. So this is how it's going to be all the edges. And in case I want to check for all the length of these edges, and just do the same thing as I had here to get all the length of the edges. Total number of edges that we have, which is 21, just as it was shown here. Perfect. So now we have a bit idea about this, our social structure that we have. Now let's see how to do some interesting stuff. So the best way is that you can be able to add, data sets, you can add some people to it, you can add different nodes to it. So let's see how to add something very simple to this. You can just create something simple. So to add this to it, it's going to be our US graph that we have. Add edge. I'm going to add somebody from it totally, right? So let's add 2 people to it. So let's add somebody that is not a president of US, but maybe an old president of US or something else. So let's call them as Lincoln. I don't know how to spell the spelling. So perfect. It's going to add this one to it. So that added it to it. In case I go back again to this place and I check for the number of nodes now. So US graph. Now it is no more the previous one. See that you have Lincoln and Franklin added to it. Now let's see how to visualize this our data set, because it's very, very important for you to visualize this, because when you're able to visualize it makes it more easier for you to see what you are doing. Right? So that is one of the advantages of visualization. Let's try how to do. So how do we visualize a data set? There are several ways of doing it. So you can just do it with the end draw. So the first method is going to be with the NS draw. That's the first method. And the next method is going to be our NS draw network. Yes, right? So the first, this option gives you the option of drawing it without giving labels, except to specify. So let's see how it's going to be. So that's just the basic idea. So you have the NS draw and then an NS draw network. So let's import matplotlib to help us do some interesting stuff. So it's going to be import mat. Perfect. So let's try and plot our first graph. So draw of our US graph. Let's see what it's going to give us. Perfect. So you see that it's starting to draw it very well, right? A very nice format. So in case you want to change some of the colors, you can be able to change the colors in a very nice way. So we have some two people here. These two people are actually the new ones that you add, obviously, but you see that it's not giving us the labels. So to get the labels, then you're going to set the labels to it. So let's see how to do that. So I'm just going to go down more. Let's set the label. So it's going to be the same stuff we have, but let's set it with the label. So with label, right, that is the option of being able to see the label that you have. Perfect. So now that's going to give us our labels in a very simple way. So we have Lincoln and Franklin, which were the two people that we added recently here because they were not connected in any way. Then you also have Ivanka, we have Dole, Bush, Clinton, and all of these. Very nice graph that we have. So that's the first method of doing it. So you can just go with NS draw, or you can just go with the NS draw and set the label. And also, in case you want to change the color, you can also do that. You can also try that one and change the color to a different color, right? So let's try that one and see. So NS draw, there are several options. Then just go with load, color, then use the normal color that we have, which can be green, red, white. So that has changed them to green, right? So you can also change the color with this particular one. So it has changed it to green. Perfect. Now you notice that anytime it runs it changes the stuff, right? It changes it. So it is randomly generated. Now let's see how to do the second method. So the second method of drawing our graph is going to be our data set we have to US graph. And without specifying anything, you'll be able to get the labels with this particular option, right? So it's going to give you the labels without specifying, which is very interesting. So I prefer to use this one when I'm working in a Jupyter notebook, right? So you are able to work on it in a very simple way, right? So that is the basic idea about it. Now let's see how to analyze this data set, which is not that bad. It is interesting here. It is very interesting, but I want to be able to see it very well. So in case you want to see it well, I just use the normal plt.figure. You set the size, so figure fixed size. Let's go to let's see show. You can actually save this one. So this is better, right? This is a better format. So in case you want to save it, you also do the same thing of plt.save figure. Then we save it as, let's say, US president, right? .png. Perfect. So that's save it. That's how to save it in a very simple way. We have something very nice. Now let's see how to do some analysis of this particular stuff. It's a very interesting data. We're going to be able to derive meaningful data from this particular stuff that we had. So just go with our analysis, doing degree of centrality, which is going to tell us the most influential person, and then the levels of connection. And we also be finding the most important connection, the best betweener, and then the shortest path. So that's what we're trying to do in this option, right? So let's see how to do each and every one of them. So the first one is that how do you get the degree of centrality? So let's see first of all the general degree or general levels of connection. So it's going to be quite simple. We have our graph already, which we had as US graph, right? That is a graph that you are working with. So that is what you are trying to find, the general level of degree. So going to be degree, pass it inside this, then going to list it perfectly for us. So this is a degree view for all of them. So Clinton has 3 different connections, Hillary has 4 different connections, Bush has 5, Obama has 5, and all of these things. Very interesting. But in case you want to find the most popular person or the degree of connection for one person, so let's say I want to find the degree of connection for Bush or Obama. So I can just take it like ns.degree, right? Then I'll just go with the US graph. Then I'll specify the person's name. So let's say I want to find for one for Obama. So we have 5, just as we had here, right? So Obama is connected to 5 different people. So these are the degree of connection, right? So Obama is having 5 degrees of connection. He's connected to 5 different people. And let's see another stuff you can also do. You can also apply the same thing for, let's say, the new person that we added to it. So we had Lincoln there. Lincoln. I don't know how to spell Lincoln. It is 1, right? Just as it's shown here. It's only connected to 1 person. That is Franklin. So that's how to work with it. And let's see another stuff you can also do. So in case you want to find the most influential person from this our data set that we have, the most influential person. Who is the most influential person among all data sets? So how do we do that? It's going to be very simple. You can just make it as this, and this way by we use a degree centrality, right? So that's the option to find the most influential person. And then it's very important because you have to find the most influential person, be able to know who to target to get the most vote or to get the most influence. So to do that is going to be very simple. So let's give that ns dot our degree centrality. Then we're going to pass in our graph. We're going to check it. So the most influential person among all of them here is we have Clinton, right? Just 1.5. We also have Hillary 0.2. We have Bush 0.25. We have all of these things, right? But the most influential, it looks to me, is Bush, Obama, and then we also have Bush and Obama are the most influential people among them. Right, so that's one way of doing it. So in case you want to sort them out, you can actually sort them out because this is a list, this is a dictionary. So you can just go with sorted. You're not sorting them, and then you're going to sort them the values of it. So that the highest, the least is 0.05, and then the highest is 0.25. So we have 2 people who are with this particular stuff. So you can actually do a simple for loop to do that. So it's going to be, let me copy it and paste so that it becomes simple. So to find the most influential, right, let's put inside this particular stuff most influential. Then let's going to look through them to get it in a very simple way. So the most influential person among them is Obama and Bush, followed by Hillary, Michelle, then Clinton, and then all of this. So that is a very simple way to find the most influential. And so if you want to target Bush, you to get a lot of people. If you want to target Obama, to get a lot of influence among them. Then let's see Trump, Laura, and all of these stuff. The list of them is Lincoln and then Franklin. Okay, perfect. So that is how to find the most influential person, the least influential person. Now let's see another stuff you can also do. So it's not just the connections. It's not just this. Right? It's finding the connection, the most influential person, which is Obama here, and then which is Bush here. Right? It's not just finding this person and this person, but sometimes also the edge, not just the node, which is the most influential person, but also the edge, right? The most important link that you need to connect to, the most important connection. So how do you find the most important connection? You're going to be using the agent vector, right? So dot agent vector. So we have the agent vector centrality. That's what we use, right? That help us to find the most important network, right? Or the most important connection. So it's going to be the same thing to ns dot agent vector centrality. We're going to pass in our particular graph, so US graph. So we have our US graph here. Then perfect. So this is the agent vector, right? So these are some of the most important connections. So we have Obama at 42, we have Bush at 36. So although Obama and then Bush are very famous, right? But based on the most important link, we realize that the highest of the most important link is Obama, right? Not just Bush. So let's try it. You can also sort it as we did previously. So let's put it inside this option. So let's put it as most important links to most important link or connection. That is the most important link means that if I'm related to this person, then I'm very, very essential. It answers the question, do you know who I am related to? That is the question that it answers, right? So let's see the most important connected link. I just go with sorted. the same thing that we had here. That's the same thing we need to do. Just copy this that we had, then use it, right? Because the same thing. Then change this from most. So if I run it, see that Obama is the most important. Wow, even based on this data set, you see from here we had Clinton, Hillary, Bush. Wow, you see that when you sorted it out, we have you have Obama as the most important link, Michelle as the most important link, Hillary, and then Bush. Wow. Before you have Law, you have Trump. Wow. So the most important link is between Obama and Michelle, and then Hillary, and then Bush. Hillary itself, not even Clinton. And then Bush, and then you also have Trump, right? So this is how the most important link works. So very, very interesting data sets. Wow. So we want to find the most shortest connection between Obama and then Bill Clinton. So that is where we go with NS short. This is closeness centrality, right? This is closeness centrality. So to find the closest centrality, just going to use the shortest path. So shortest path, right? That's what's going to help us to find the closeness centrality. So let's go as closeness. Very important and very useful. So let's try that one for our stuff. So we have our shortest path. So we want to find the shortest path between Obama, who was one of our nodes, and then Clinton, right? So we had Clinton. Then of what? We are finding that of Obama and then Clinton of our US degree data. US graph, thank you. US graph. Right, the spelling of Obama, not Obama. So let's try it and see. So the shortest path between Obama and Clinton is that to be able to get to Obama, to get to Clinton, you have to go through Obama, you have to go through Trump, Hillary, and then Clinton. That is the shortest path. So you can also try it for several of them. So let's try it for another option. It's quite interesting when you understand these things. So let's try it between Obama and then let's say Obama and another person. Let's not use Obama. Let's use a different person. Let's Trump. To find the shortest link between Trump and then Bush. What is the shortest link between Trump and Bush? So wow, Obama is the shortest link between Trump and Bush. In case you want to find the shortest link between Ivanka, right, and then Laura. So Ivanka, and then you also want to find that one between Laura Bush, which is, so you have to get to Laura, you have to pass through Michelle, right? That is the shortest link. So it's very, very interesting data set. Perfect. So that is how to do that. Now let's move on to the next option of, let's move on to find the betweener, right? So who is going to be our betweener? So the betweener centrality, betweener act as a bridge between them, right? So to add as a bridge or the connector, bridge or connector. So it's very, very important. So in case you want to be able to get the, apart from using the shortest path to find the shortest path to a person, you can also use the betweener to find the person that is connected to a lot of people, right? So let's see how to do that. So let's see our data set already, our graph. So this was the graph that we have. So we want to find this is looking very funny. We want to find the best betweener between all of them. Then we're just going to use that betweener option. So it's going to be like this. ns dot between. We have betweener centrality. That's what we use it. So betweener centrality. Then we're going to pass it our graph. So our graph then perfect. So we're going to list them perfectly for us, right? So we have Clinton, Hillary, Bush. The reason it is sorting this one, this is being sorted based on alphabetical order, right? So you need to want to sort by the values itself. You can just go with the normal sort that we have been using. So that is how to find the best betweener among them. So let's try and see how to do that with the famous formula, which is this that you have been using so far. Then here we'll be changing it from, let's call that best connector or best betweener, right? That's what we try to do. Best connector or best betweener. Then just going to create our best connector. It's going to be the centrality that we have, which is ns betweener centrality. Then we're going to pass in our graph, US graph, right? So if you check it, wow, so the best connector is Bush and then Obama, and actually it makes sense. Mostly the most influential people are usually the most connected people, right? The people that are usually connected the most. So you have Bush, Obama, you have Hillary, you have Clinton, and then so forth. So that is how to work on this particular stuff. So perfect. So now let's move on to some interesting stuff. Then we'll be able to complete, because it seems that you are talking too much. Okay, so let's see how to build a subgroup from it. So to build a subgroup from this, it's going to be very simple. You have two different methods. How do you retrieve all the nodes connected to a particular person, right? So in case you want to find the nodes that are connected to this person, right? In case you want to find another group, you want to find association between them, and also work on that. So let's see first of all the first one, finding a subgroup. The second one, finding an association. So it's going to be very simple. We're using the breadth first sheet, right? It's going to be using the breadth first. We're going to be something like this. So ns.bf, can just go with breadth first set like this, or you can just go with the simple format of bf s3, right? Then we're going to supply the graph, us graph, that is the graph itself, and then we're going to supply the particular person. So let's go with Obama. So perfect has created something very interesting. So in case I want to put them together as one persons who are connected to Obama, who was a president. So let's call it as group 1. Right, and then let's create another group which is going to be not connected to Obama but connected to Bush, right? Instead of somebody different, let's put Bush. So this is going to be group 2, right? And I'm going to create another one with a female president, one connected to Clinton or Hillary, right? Go to group 3. Right, so with this we need to find different groups, and we can be able to build even the association between them. So let's plot them to see what we have. So ls.draw, perfect. So this is a totally different group. It's a totally different group altogether. Wow. Then you can also draw another one for all the different groups, right? So you are going to build a totally different group where the people are connected to the person that we have, right? So the person that we chose for the group 1 was Obama. So these are the people connected to Obama. So all these people here are connected to Obama, all these people are connected to Obama. Same way if you try for group 2, which is for Bush, you're also going to find all these people are connected to Bush, right? I think Bush should be around here. Then the next one is going to be who's connected to Hillary, 3. Perfect, right? So very interesting, right? So all these are people connected to Hillary. Very interesting. We're going to build subgroups from it. So the next method is that we can also use, instead of using the BF tree, you can also use this particular option of NS means, right? Which is also another option you can also use. So copy this one. Then let's see that one. So this, we have our US graph. Then the node that we want to check on, let's use somebody like Trump. So these are the people who are connected to Trump. Very interesting. So Trump is there, and all these people who are connected to Trump. Very interesting. Okay, now let's see the last thing you can also do in case you want to find the association between them. Just use the ns. Use the ns.clustering to do that, right? So that is what we're using. You cluster or clustering. That's any of them work. Let's try the last one for that. So ns.clustering. Graph. Okay, so that's the clustering. So if you cluster it, like some of them is 0, 0, some of them are 0, some of them are 1. So you're trying to find the association between each and every one of them. Right? Very interesting data set. So thank you for watching this long tutorial. So in case you have any question or contribution, can you just put inside the comment section so that everybody can benefit. And please don't forget to subscribe and share. In case you need help, also you can also check the links below for more.